Good morning. Okay, today we are going to take a look at a beast of a problem involving simplifying rational expressions, and this is going to really give us a full review of factoring, difference of squares, difference of cubes, factoring polynomials, synthetic division, long division with polynomials. This one problem is going to give us a chance to look at all of it. So let's go. Okay, so here is our beastly problem. Now, if you want to try to solve this on your own, press pause, copy this down, play around with it, and then press play and see where we go. So let's talk about where we would even begin. So I find always with math, you want to do the easiest stuff first and then see how that informs the tougher stuff. So for example, this long 5-term polynomial, I will term that tougher stuff because it's an odd number of terms. We can't even really start by grouping. Leave that for last. Let's see how the rest of this informs things. Okay, the first thing I will do is I will note this division of a fraction and I will rewrite that as multiplication. So don't forget the little jingle. With division of fractions, it's don't ask why, just flip and multiply. Okay, so now I have a string of expressions that I'm multiplying together, which actually means, because this is how multiplication works, I multiply all the tops together and all the bottoms together and extend my fraction line. Okay, so this times this times this is my numerator, and this times this times this is my denominator. And as you can see, that's going to leave us plenty of opportunities for canceling when we begin to factor. Okay, so again, I'm going to ignore my giant, but I'm going to take a look at this. Whenever I see a 2-term expression like this, and especially when I see an x squared, I know that what's probably happening? That's correct, difference of squares. If you don't remember that, check out this video. Otherwise, we know the square root of 169 is 13. The square root of x squared is x. Therefore, this factors into 13 plus x times 13 minus x. Okay, moving on to my next expression. I have 20x squared plus 23x minus 7. Okay, I'm gonna, over the course of this video, show you a lot of different ways to factor quadratic expressions. For this guy right here, because I have a coefficient of my x squared, I'm going to show you a European method, the AC method. So the way that method goes is as follows. I am going to start by rewriting this first expression by omitting the a, the coefficient of my x squared, repeating my bx term, and changing this last term into AC, a times c, 20 times negative 7. I am now going to factor this. Well, I know that 140 breaks into the following factors. And when I run through these to figure out which ones could combine to make a 23, I see 5 and 28 look pretty good. And because my 23 is positive, I know my larger of those two needs to be the positive one, and my smaller one wants to be the negative. So that's 28 minus 5 gets me positive 23, whereas 28 times negative 5 gets me my 140. So my final step here is I'm going to take this 20 that I omitted from the beginning, and I'm going to divide it into each of those factors I just found. I'm going to simplify each of those fractions I just created. Now, if either of these simplified into an integer, I'm done. Since neither of these did, I'm going to take this denominator here and I'm going to swing it around to become the coefficient of that x. And that is my fully factored version of where I started. You can see that the 5x times 4x gets me that 20. You can see that the 7 times negative 1 gets me my negative 7. And then my inside outside gets me plus 28x minus 5x, which come together to be my positive 23. So this AC method is a really effective way when you've got a coefficient of your x squared term. So now I'm going to take these two factors and I'm going to write them in instead of this denominator that I just factored. Okay, now I'm going to take a look at this quadratic that's on the top here, x squared minus 6x minus 91. I do not have a coefficient of my x squared term, so I'm just going to use the x method. So to remind you, and if you aren't familiar with this, go check out this video. The x method goes like this. Up top goes my c, or technically my ac, but a is 1 in this case, so that's 91. What goes down below is my middle term, my b, my 6, and I'm asking the question what multiplies to 91 and it adds to negative 6. So again, I'm going to make a factor list. And that's a pretty short factor list because it's the multiplication of two primes. And happily, 13 and 7, I can see that'll come together as a negative 6. Because I need it to be negative, my larger of the two factors wants to be negative. And because I had no coefficient of my x, that's it. This is what goes in the parentheses. So I can now rewrite this quadratic as x plus 7, x minus 13. Okay, now, before we go any further, does everybody see that we have a 13 minus x here and we have an x minus 13 here? And I don't know about you, but I'm just itching to cancel them. They're so close. Okay, here's how to make them exactly the same. When you have the same terms, but they have the opposite signs from what you need, I'm going to take this guy and I'm going to factor a -1 out of each of these terms. Factor means divide. When I divide 13 by -1, I'm left with negative 13. When I divide negative x by -1, I'm left with plus x. And I can rewrite the terms of addition in either direction. So I can rewrite that as x plus negative 13 or x minus 13. And now I have made these the same. So when you factor a -1 out of a term, you are able to switch the positive negative of each term. So I'm going to take that denominator here and rewrite it as -1 times x plus 13, x minus 13. I just took that 13 plus x and rewrote it as x plus 13 because, as I just said, with addition, you can switch the order of the terms, no problem. Okay, so you can already see we've uncovered one thing that will cancel away. Okay, let's keep going. If we look in our denominator here, 8x to the third plus 27, that should be ringing some bells. Anybody? Yes, that is a sum of cubes. If you are not familiar with this, go check out this video. Otherwise, let's remember the following. A cubed plus b cubed factors into a plus b times a squared minus ab plus b squared. So if I have 8x cubed plus 27, that means my a is the cube root of ax cubed, or just 2x, and my b is the cube root of 27, which is just 3. So now I plug it into my formula here, and that factors into 2x plus 3 times 4x squared minus 6x plus 9. So I can substitute that in right there. Okay, next up, we've got this monster. So let's go ahead and use our AC method again. We're going to start by rewriting this, omitting that A, but multiplying it into the C. I'm going to go ahead and factor that guy. Okay, I'm looking to create that 37. I can see that's going to happen with my 2 and my 39. My middle term wants to be positive, so my 39 is the positive one. But I'm not done because once upon a time this came with a coefficient. So I'm now going to divide that A into each of my final terms here. I'm going to simplify each of those fractions. Minus 2/3 stays minus 2/3, but 39 over 3 becomes 13. This is an integer, so this factor's done. This is not an integer, so I take my 3 and multiply it to the front. And I have now factored 3x squared plus 37x minus 26. All right, and does everybody see I've got an x plus 13 and an x plus 13, so things are going to start to cancel now. I have done all of the quote-unquote easy work. I am now left with this beastly thing, but because I was told that this problem simplifies, I can be fairly certain that one of these things, if not more of them, are going to divide evenly into this beast. Let's go ahead and start to work on it. Now, there are a couple different ways we can play with this. We can guide ourselves with the P over Q method of finding potential factors. Okay, what P over Q says is that if this is my ginormous polynomial, then the only things that could evenly divide into it are things where the numerator is a factor of my final term and the denominator is a factor of my first coefficient. So that means all the factors of 42 over all the factors of 120. So when we break 42 apart, we find 1, 2, 3, 6, 7, 14, 21, 42. Okay, when we break 120 apart, we get 1, 2, 3, 4, 5, 6, 10, 12, 20, 24, 30, 40, 60, 120. So we have lots of possibilities. And not only do we have all of these possible fractions, this comes with a plus or minus. So we have the positives and the negatives. But let's guide ourselves by the factors we've got down here. If 5x plus 7, if 5x plus 7 is one of our zeros, then x equals negative 7/5 is one of our potential roots. Okay, same thing. 1/4 is a potential root. And if we look through, we definitely see 7 over 5. We definitely see 1 over 4. If we take a look here, negative 3/2 is a possibility, 3/2. So we're going to take a stab at this now with two different methods. We're going to do synthetic division and we're going to do polynomial long division. Okay, we're going to start with old-fashioned polynomial division. So I'm going to take my 5x plus 7 and I'm going to divide it into this monster. Okay, so if you've not done polynomial long division in a while, go take a look at this video. Otherwise, here we go. We cover everything up but the first term and the first term, and we go 5x divides into 120x to the fourth how many times? Okay, 5 divides into 120 24 times, and x divides into x to the fourth, x to the third times. Okay, we write that right on top of the one that we just investigated, but now we're going to multiply through, we're going to distribute it to both terms here. 24x cubed times 5x equals 120x to the fourth. It better, if that doesn't match up, you didn't do this part right. And then 24x cubed times 7 is 168x cubed. And now we subtract 120x to the fourth minus 120x to the fourth, 0. 238x cubed minus 168x cubed, 70x cubed, and we bring down our next term. We rinse and repeat. We're looking only at 5x divided into 70x cubed. That equals 14x squared. Multiply that through. That equals that. Subtract 145x squared. Bring down your next term. 5x divides into negative 145x squared, negative 29x times, multiply through, do this subtraction. Negative 145x squared minus 145x squared, that disappears. Negative 173x minus, that means plus, 203x leaves us with 30x. Bring down our final term. And here's the glory. 5x divided into 30x is 6. Multiply through is that. Subtract is glory. Okay, so 5x plus 7 is a factor of this beast, leaving us with this much as a remainder to keep doing our division with. Okay, that is polynomial long division. And I'm going to just keep track of the factors we found up here. Okay, now I'm going to show you how to proceed using synthetic division. So next, let's work with 4x minus 1 and see if it happens to be a factor of this. But we're going to do the synthetic division version. So the synthetic division says, I cannot work with a coefficient of my x, okay? So this factor has to turn into the following. 4 times x minus 1/4. okay? You have to have no coefficient of your x. And so now I'm going to plug my 0 in. So that means I'm plugging in 1/4. That was part of our factor list. So my 1/4 exists there. And I am going to take these coefficients and I'm going to line them up here. I'm going to make a line and I'm going to bring my first coefficient down below the line. Synthetic division is the opposite of polynomial long division. With polynomial long division, we multiplied, subtracted, multiplied, subtracted. With this, we're going to multiply, add, multiply, add. So 1/4 times 24, that's 6, and I add. 1/4 times 20, that's 5, and I add. 1/4 times negative 24, that's negative 6, and I add. And there's my magic 0, telling me that this, in fact, is a factor. If I started with x to the third, then my final line here is 1 degree less. So 24x squared plus 20x minus 24. So I just found out that x minus 1/4 is also a factor, but when I look at what I have left, each of these terms is divisible by 4. I can pull a 4 out of each of these terms, can bring that 4 up onto this line as well, and I can multiply that 4 into both terms in order to give me a factor that I know is going to cancel with the bottom. So this is something to keep in mind if you choose to use synthetic division to chew your way through this. Just don't forget that after you change your factor to make it synthetic division kosher, to make it so it says x plus or minus b, that at the end on your last line, pull that same number out of what's left in order to reconvert that factor back into the thing you were hoping to get. On this bottom line here, this is just a quadratic. So I'm no longer going to use polynomial or synthetic. I'm going to go ahead and use one of my quadratic factoring methods. So I have 6x squared plus 5x minus 6 to factor. I am suspicious that this is going to be part of it, so I'm going to go ahead and just use parentheses method and sort of stab and grab. If in fact this guy gets to cancel away, well, plus 3, so over here I would want a minus 2 in order to make that multiply to my negative 6. Up front, if I have a 2x there, I would probably want a 3x minus 2 here, 6x squared minus 4x plus 9x, 9x minus 4x, yep, that's my 5x. And then 3 times negative 2, negative 6. So those are my last factors. So I had a 4-degree polynomial, 1, 2, 3, 4, perfect. All right, let's rewrite it as such. Okay, now comes the moment you've been waiting for. Let's do some canceling. I see a 5x plus 7 and a 5x plus 7. Those can go away. And then I want to note somewhere x does not equal 7/5 because that would have been in the bottom and that's a no-fly zone. I see a 4x minus 1 and a 4x minus 1. Those cancel. Okay, can't be 1/4 either. I see a 2x plus 3 and a 2x plus 3. Not a negative 3 over 2 either. I see an x plus 13 and an x plus 13. I see a x minus 13 and an x minus 13. Okay, these are all the things x can't be because that would put a 0 on the bottom of the function. Now I'm going to put back together what I have left. On the top, I have an 3x minus 2 and a 3x minus 2. That does not make 2 3x minus 2s. That makes 3x minus 2 squared. And I have an x plus 7. On the bottom, I have a negative 1. I'm going to put that on the outside of the whole fraction. Don't forget, negatives can attach to the bottom, the top, or outside of the whole thing. It's all the same. I've gotten rid of everything except this nasty little quadratic that doesn't factor evenly. And that, my friends, is the solution to the beast. Okay, congratulations. You just did a massive Algebra 2 review. Great work. If you want to further look at any of those topics, look through my channel. I've got videos on everything I just did, slower, with more attention to detail on that specific technique. Leave any questions in the comments. Feel free to subscribe to my channel so you know when I put out new videos. And as always, keep on mathing. Great work today.